Okay, so let's start with the next tutorial, that is the last in this series. So, Simply's data pipeline architecture. Startup Simply's data pipeline architecture is well automated and designed with the simplicity and scale in mind. Fivetran, Snowflake, DBT, Monte Carlo, and Looker are solutions that integrate very well together. Head of Data Michael Sheldon says, because we had this mandate as a data team to support the entire company, we we need a data stack that could solve two central issues. One, to centralize all of the data from all the different parts of the company in one stable place where everyone could use and refer to as a source of truth, and two, to enable us to have enough time to really focus on the insights and not just the data infrastructure itself. Backcountry's data pipeline architecture. Backcountry relies on data to power nearly every facet of its business, including customer acquisition, segmentation, and personalization, marketing, merchandising, and customer support. But the data team was ingesting large amounts of data from an ever increasing number of sources, and the legacy system wasn't able to perform at scale. So the backcountry team had to move quickly to migrate from a legacy stack to a modern data stack. They built their stack around the Google Cloud Platform, including BigQuery, Looker, Airflow, and Fivetran. Backcountry's data pipeline architecture. Backcountry relies on data to power nearly every facet of its business, including customer acquisition, segmentation, and personalization, marketing, merchandising, and customer support. But the data team was ingesting large amounts of data from an ever increasing number of sources, and the legacy system wasn't able to perform at scale. So the black country or the backcountry team had to move quickly to migrate from the legacy stack to a modern data stack. They built their stack around the Google Cloud Platform, including BigQuery, Looker, Airflow, and Fivetran. BlaBlaCar's data pipeline architecture. BlaBlaCar's data pipeline architecture is part of its data mesh implementation. This transition to a more decentralized structure was critical to accelerate team efficiency following the two M&As. We had some new use cases around data science that were hard to fit into our existing organization. That's essentially that triggered the discussion of we need to do things differently, said Emmanuel Martin Shave, VP of Data Analytics. Data's data pipeline architecture. VP of Data Lair Solomon got to build this modern data architecture from the ground up, and he stood it up fast. He said, choosing the right technology stack is critical for the fast growing startup. I wanted to select technologies that would scale with our fast growing business, he easy and be easy to use and seamlessly integrate with our existing systems. How to build a data pipeline step by step. So we know the importance of data. Also, we know data plays a significant role in business growth and digital initiatives for approximately 94% of enterprises. However, the full potential of these data assets often remains untapped, primarily due to the scattered nature of the data. The solution lies in, in constructing a structured data pipeline, a task that can be source intensive and time consuming. A simple pipeline may take weeks to build, while a more complex one could span months. Therefore, it is imperative for our organization to invest in appropriate tools and technologies to streamline the process of building a data pipeline. Let us now learn how to build a robust data pipeline. Building a data pipeline is a multi step process that requires careful planning and execution. Here are some steps to build a data pipeline. Step number one, define your goals. The first step in building a data pipeline is to clearly outline your objective. These could be this could be enable real-time analytics, facilitate machine learning models, or ensure data synchronization across systems. Your goals will guide the design, complexity, and scalability of your pipeline. Consider the specific data requirements, the frequency of data updates, and desired speed of data processing and analysis. Then second is identify data sources. Recognizing your data sources is a critical or is a crucial step in building a data pipeline. Data sources can be broadly divided into six categories. Databases. Databases could be relational like MySQL, PostgreSQL, or non-relational like MongoDB, Cassandra. Then cloud storage. Data can also be stored in the cloud platform like AWS S3, Google Cloud Storage, or Azure Blob Storage. Real-time data streams. These are continuous data sources like IoT devices, social media, feeds, or log files. File sources. Data may originate from files including formats such as CSV, Excel, JSON, or other file-based storage systems. APIs, application programming interfaces. Data can be extracted from APIs that provide a direct connection to various web service and external platforms. Understanding the nature, format, and the volume of these data sources is essential as it impacts the subsequent stages of ingestion and transformation. Step number three, that is determine the data ingestion strategy. Next, you need to extract, integration, and incorporate data from diverse sources into your pipeline. There are two primary methods of data ingestion. Batch ingestion. This method involves collecting data over a period of time and processing it as a group. It's suitable for large volumes of static data where real-time insights are not required. Real-time ingestion. In this method, data is processed immediately as it arrives. It's ideal for scenarios where real-time insights are crucial, such as fraud detection or system monitoring. Step 4. Design the data processing plan. You will need to clean, validate, and structure the ingested data into a format suitable for analysis. There are two main approaches to data transformation. ETL, extract, transform, load. Here you extract data from the source into a staging server, transform it, and then load it to the destination. This approach is typically used when dealing with smaller volumes of data or when the transformed data needs to be used by multiple downstream applications. ELT, extract, load, transform. In this approach, you extract data from the source, load it to the destination, and then transform it within the destination server. This eliminates the need to load data on a staging server, making it preferable for handling larger volumes of data on a big data environment. The data transformation process in ELT is similar to ETL but occurs after the data has been loaded into a destination. Decide where they store the information. Next, you will store the processed data for further use. This could be a traditional data warehouse like Amazon, Redshift, or structured data. A data lake like Google Cloud Storage, or semi-structured or unstructured data, or a database system like PostgreSQL for transactional data. The choice of destination depends on the nature of the data, the use case, and the specific data analytics requirement. Step 6, establish the workflow. At this stage, it's important to define the sequence of operations in the pipeline. This includes specifying the order of tasks, managing dependencies between tasks, handling errors, and setting up retries or notifications in the case of failures. This step is crucial to ensure the smooth operation of the pipeline and to handle any issues that might arise promptly. It involves creating data validation checks and defining procedures for error handling and recovery. Next step, set a monitoring framework. It's crucial to monitor data pipeline performance to ensure it's working as expected. This involves tracking the flow of data through the pipeline, checking for errors or bottlenecks that might slow down data processing, and monitoring resource usage to ensure the pipeline is operating efficiently. Monitoring, helping, Monitoring helps detect and resolve issues before they affect the performance of the pipeline or data quality. Next step, implement data consumption layer. Finally, you will need to create a reliable interface through which end users or applications access the processed data. The, this could be business intelligence tool that provides data visualization capabilities, a reporting tool that generates detailed reports, or an API that allows other applications to interact with the data. The data consumption layer needs to be designed and easy access to the data. Best practices for building data pipelines: streamline development and deployment. Implement continuous integration, continuous deployment, that is CI/CD is the key here. CI/CD automates the process of integrating code changes and deploying those changes to the production environment. This means that any updates for improvements to the pipeline can be implemented rapidly and reliably, ensuring the pipeline is always operating it at its best. Maintain consistency. Version control systems help achieve consistency in collaborative development environments. They track and manage changes to the code base, establishing enabling simultaneous work without underwriting changes, and providing the ability to revert to previous code versions when necessary. Optimize data management. Data partitioning divides a large database into smaller, more manageable segments based on specific criteria, improving query performance and streamlining data management tasks. Leverage modern architecture. Software architecture like containers and microservices can significantly improve the scalability and reliability of your data pipeline. Containers encapsulates an application and its dependency on a single unit that can run consistently across platforms. Microservices create an application as a collection of independent services, promoting better scalability and easier debugging. Ensure data security. As data moves through various stages of the pipeline, from extraction and transformation to loading, it's crucial to protect it from unauthorized access and potential breaches. This involves implementing data encryption, access control, and regular vulnerability testing to protect sensitive information. Compliance with the relevant data safety regulations such as GDPR and HIPAA is essential, particularly in the sector dealing with personal data such as healthcare and finance. Shifting from manual to automated data pipelines. Building data pipelines manually, Python or for data pipelines, is inherently a time consuming and resource intensive process, making it susceptible to delays, errors, and inefficiencies. The transition to automated data pipeline tools addresses these challenges, streamlining processes for greater efficiency and resource optimization. These advanced tools play a pivotal role in streamlining the entire process, offering advantages such as reduced development time, minimized errors, and enhanced scalability. By automating repetitive tasks, they allow organizations to expedite pipeline developed development while maintaining the high level of accuracy. Thank you.